Next example, where we have a quadratic function, let's calculate the difference quotient for it. So again, our first step, let's go ahead and find f of x plus h. That's the missing part from the difference quotient, right? We got to find that, and then we can plug it right into the difference quotient and simplify and have our answer. So this is the missing part of the numerator of the difference quotient. So let's go ahead and do the work together. So f of x plus h, well, we've got a couple of x terms here. So two places we're going to take out x and plug in x plus h. So I got 8 times x plus h squared minus 4 times x plus h minus 1. So again, evaluating my function with input x plus h. Be careful simplifying. Now we do have to square x plus h. So that means we need to expand that, right? That's x plus h times x plus h. So you can go ahead and distribute or FOIL out however you work your binomials. And while we're at it, let's go ahead and distribute, right? This next, we got parentheses here, minus 4 times x minus 4x minus 4 times h minus 4h minus 1. And again, working on this square, right, of x plus h. And just be careful here as we multiply through. Let's go ahead and do this together. We got the x to distribute through. X times x is x squared. X times h is xh. Now we got to distribute the h through. And h times x, which is also a product of xh, doesn't matter the order. Multiplication is commutative. I'm going to write it in the same order just so we can notice they are like terms. H times h is h squared. And then we've got our minus 4x minus 4h minus 1. And now we can go ahead and distribute. Right? Well, before we do that, just don't distribute yet. Let's go ahead and combine like terms. We can make that a little simpler here, right inside the parentheses. We have a couple of xh terms. Let's go ahead and add those together first. So as we're simplifying down, this is 8 times x squared plus 2xh. So we add the 2xh term together plus the h squared. So again, combining our like terms. And then we've got our minus 4x minus 4h minus 1. Now let's distribute. As we do that, we got 3 terms, right? Multiply this h through with. So 8 times x squared is 8x squared. 8 times 2xh is 16xh. 8 times h squared is 8h squared. And our minus 4x minus 4h minus 1. And at that point, if we had any like terms, right, we'd go ahead and combine them. But here's what we're looking for. We found the value of f, right, at x plus h. So that's that missing part, right? We got to plug this in, right, to our difference quotient. So we're going ready to go plug in now, our next step. So let's go ahead and write that out right here beside it. So this implies, right, this implies dq, difference quotient, equal to, again, f of x plus h minus f of x, all divided by h. So that's equal to, right, and we'll go ahead and put it in parentheses, f of x plus h, which is 8x squared, plus 16xh, plus 8h squared, minus 4x, minus 4h, minus 1. And then we got to subtract. Right now we got to subtract the f of x function that we were given, which is 8x squared minus 4x minus 1. Again, all divided by h. So as we simplify, right, let's go ahead and distribute. So we got a clear parentheses. Do that in our next step. We're going to combine in like terms. So we have our 8x squared plus 16xh plus 8h squared minus 4x minus 4h minus 1 minus the 8x squared minus a minus 4x becomes plus 4x minus negative 1 plus 1. Again, all divided by h. Right? And then we notice now our like terms come into play. So for example, we got a 8x squared up here at the front, and we got another x squared term. We have the opposite, so they add up to 0. They cancel out. We also have a couple x terms, right? We have a negative 4x, we have a positive 4x. They add up to 0. We also have a minus 1. We have a plus 1. They add up to 0. So it's simplifying nicely. So in the end, what are we left with in our difference quotient? We're left with 3 terms in the numerator. We've got a 16xh plus a 8h squared minus a 4h, all divided by h. Well, it's a fraction. We want to try to reduce it. We want to look for common factors, right? So we'll notice in the numerator, we've got a common factor of h. So let's go ahead and bring that out. So I'll make that note. We have a GCF of h. So if we bring out that greatest common factor of h, we'll be left with 6x in the first term, right? 6x times h, 6xh. So we factor out an h from 8h squared, where we're left with 8h. And then with minus 4h, we factor out the h, we're left with minus 4. And again, all of this is being divided by h. And there's that common factor. So in the end, what is our difference quotient? 6x plus 8h minus 4. There's our difference quotient. Or this problem, right? And this was a 16. So correct me, I don't know where I dropped my 1 off. It was 16x. So it's been 16x plus 8h minus 4. But there it is. There's my difference quotient in this example. All right. So again, you see your difference quotient. Your work is really in the simplifying.